Hey everyone, so this is just going to be a quick video of how to do CS188 discussion 11 because a lot of students had questions on this discussion worksheet, so I'm just going to do a quick run through and hopefully it'll help some of y'all understand what happened in discussion. So the big idea here is we have a neural net. So in the last discussion you saw something called perceptron. So perceptron is this one little box. Let's draw something out. So for perceptron, we had this box where you had a couple inputs, as many as you wanted, and then for each input you had a corresponding weight. And what perceptron did was you did a dot product between all of your inputs and all of the weights. So you multiplied each input by its corresponding weight, summed all that together, and then you applied an activation function to that. So pretty much the big idea here is you would dot product your weight vector with your input vector, and if that passed a threshold, the perceptron outputs some value. And this is the activation function you probably remember, the perceptron activation function. Just to refresh your memory, let's pick fun colors. The way the perceptron activation function worked was that if your input was less than 0, over here, you would output 0. And if the output to this activation function was bigger than 0, you would output a 1. So the big idea here was, we did the dot product between our inputs and our weights, and then we checked whether or not that was bigger than 0. And we output the corresponding value. So that's the idea of a neuron. It's a classifier that takes an input, uses some weights, and then uses an activation function to see what the output value should be. But the thing we kind of swept under the rug when we talked about perceptron was that there are multiple choices for this activation function. So actually, depending on what you choose for this, you'll get a neuron that behaves differently. The other really cool thing you can do is why stop at just one neuron? So what you'll notice in this drawing is here I've chained together a bunch of perceptrons. And what I'm doing is I'm taking the output from one perceptron and actually feeding it as the input to a second. And this is actually really cool because now I can compose the outputs of all of these classifiers. And at the end, get one final output from the last unit. So this is a really cool idea. We saw last time, in last section, how you kind of deal with just one box here, one neuron or one perceptron. But if you actually connect them together, you can get a bunch of really crazy cool things to happen. So we have a name for this thing where you kind of chain together a bunch of neurons. It's called a neural net. And the reason we care is, pick your favorite color. Apologies, I am tired. So, we saw last time that perceptron on something like this. This was frowny face. This was bad. Because perceptron only works with data that is linearly separable. And this is very unseparable. There is no line you can draw here. But the cool thing with neural nets is, if I connect my neurons in a bunch of crazy ways like we have here, I can express some really, really crazy functions. So for example, with a neural net, I could actually do a function that looked like this, and actually separate the pluses from the zeros. And that's kind of the high-level overview of why we care.